episode of Advantest Talks Semi. I'm your host, Keith Schaub. In this episode, we explored the newly announced Advantest Cloud Solutions. Joined by Benjamin Lobmueller, the ACS business manager, Benjamin walks us through some AI history and how AI has progressed from IBM's Deep Blue, the first computer AI to defeat a world chess champion, his early IBM Watson days where Watson's AI handedly defeated the world Jeopardy champions, to today and how Advantest Cloud Solutions is innovating across the entire semiconductor value chain. Let's listen in. So Benjamin, welcome to Advantest Talk Semi.
Thanks, Keith. I'm glad to be here.
Before we jump into it, I wanted to take a step back and talk a little bit about the past, where I think it was in 1997, we had Deep Blue that beat Garry Kasparov. It was the first time a chess champion had lost to an artificial intelligence. And pretty much after that, the chess AI took over and could beat any of the top grandmasters. Fast forward to 2011, and we had the pivotal moment where IBM's Watson beat two of the greatest Jeopardy champions, which you were at IBM at the time. So I thought maybe you could give us some color on that.
Sure. So, I think you started right there with the Deep Blue, right? Deep Blue, mind blowing that it was possible, right? And the whole point of it was that at this point, there still was this suspicion, okay, it's endlessly complex. There's billions of options, but I kind of in my head always thought, okay, well, they just figured out to program a clever algorithm, right? So they had tons of if this, then that, and they were really clever. And that's the way that they could beat Kasparov. So actually, Deep Blue already was a little bit more complex than that, but fair to say, it wasn't that far off either, right? So it was like traditional computing, allowing very clever algorithms to do a lot of permutations and thus compute optimal strategy according to the situation on the chessboard. Now, fast forward when I was actually at IBM, and I was part of the Germany, Austria, Switzerland market segment management team back then. When I got my first briefing with the Watson team, and they explained to us basically how they are doing it, I was blown away because basically the high level point was we took Wikipedia and we fed that into this AI network, and it from that was capable of beating Ken Jennings, which was unheard of. I didn't think it was possible. It was fun to see because the two human players really took it in stride, right? And from an entertainment point of view, it was one of the
main things that it did, besides scaring a lot of people and becoming an infamous moment, is it opened up the door to a lot of new industries. Yes. and showed here's some real interesting value that can be brought to your customers or to your markets using this type of technology. And I think one of the other things you worked in the legal department, if you think about it, the way that lawyers have to write documents, understand documents, it's very similar in the way that Watson had to understand the Jeopardy questions. So it was a natural progression to, hey, we can use this in the legal market, and maybe take a minute or so and tell us how it got used there.
Yeah, you had it right. For us, the post Watson year for me was my best year in that job, and it was just because there were so many people who came to us who had interesting ideas and felt like, hey, I see this technology and I immediately have an idea how I could use that, right? And it was in healthcare, where there was hospitals who had patient records that they wanted to have fed through such a system. There were repair shops like in automotive who were using that to do then predictive analytics, going back and looking in which place in the factory there were problems happening based on the reports that the repair guys in the field put in. And the challenge, I would say, of that was really that a lot of these problems are not well defined. So the beauty is where it worked was in Jeopardy, we had that cache of example data. So we had that cache of right and wrong that was extensive, right? We had the whole
Mm-hmm.
past history of Jeopardy, and thus we had a narrowly defined problem. Where do we need to find an answer? What's our input source? Wikipedia and a couple of other reference documents, and we could build it so that it worked. And where we struggled, probably in healthcare, right, where a physician comes in, doesn't understand the technology and thinks he can just feed in 100,000 cancer patient records and the system will tell him how to better do diagnosis in the future on cancer. And that's just not the way Watson worked. You don't have data that allows you to do that in reverse. So that was a bit of a challenge. Nevertheless, to get these problems were very interesting. So a little bit later, when I started with a small startup in the legal industry, we had a similar situation. There are tons of companies that go out and pretend they can just feed in case descriptions and then feed in the judge's decision and now have a machine that predicts immediately, once it sees a certain situation, and it can predict how will the judge decide. And again, all of these make maybe for interesting, examples. You can try to build such a system, but maybe it gets it right 60% of the time, right?
I heard it's a better predictor is if the judge has had lunch.
Yeah, and us humans are the ones who can adopt to that, and that's a great example. I mean, if you pay very little money for your lawyer, then he will be overworked and he will not have time to think about whether he should try to get the case in front of the judge before in the AM or in the PM, because he's just glad to get the date at all. But if you
Mm-hmm.
pay like for one of those $1,000 per hour law firms, they have enough people working on that case and they have enough connections and can pull the right strings to get that case in front of the judge at the perfect time for when it's convenient to you. And that's really why these guys are so expensive. They take care of everything. They take a holistic view of the problem, right? And they can adapt quickly. That's what we humans can do. That's what we are great at. So the problem we tackled with our company was narrow, right? We said, we looked at class litigation, places where you have thousands or hundreds of thousands of litigants who sue a company. Famous case recently, one in the UK, Merrick's. Basically, every citizen in the UK who was eligible to have a credit card sued in a class litigation MasterCard, and they won. Every citizen of the UK gets, I think, £300, the biggest win in antitrust litigation ever, I think. How do you do these cases? Well, you have to be able to deal with every litigant in some way, shape, or form. And we built an AI system that was just doing this narrow problem of taking a set of criteria for a document and checking them and extracting the relevant data. So, for instance, purchase price and party names and things like that, and could check for is the document signed in the field where the AI system has learned to expect that a signature should be there. But the important part is the problem has to be narrow. But electrical engineers understand power, right? Electricity. And you understand there is a thermal envelope that you have. And in tests, we do so extremely, right? Because we have,
Mm-hmm.
scan tests, which taxes the device. It will never be taxed in real life. So this is something that we understand very well. It's sad to say, but Google took the scepter from IBM in these AI showcases with their Google Alpha Deep Brain
Mm-hmm.
projects. And what they did recently is, right, they built a chess AI that is capable of beating every human player out there. And it's now even capable of beating any other computer system out there. So even the smartest algorithm-based deep blue style computers can be beat by Google's system. And Google's system was not programmed. It just played chess against itself. So it only got the rules of chess, then it got the proper neural network, and then it started playing chess against itself. To train this neural network, Google probably used the energy of a small city for a week. A lot of the stuff that they do really is requiring tremendous amounts of energy to get right, especially around deep learning for these wide problems. So if it's not a narrow problem.
That's applicable for us now. And so Advantest, we recently announced the Advantest Cloud Solutions, which now we in our industry are also bringing AI, machine learning, and deep learning into the Advantest test ecosystem. And it's great that you have such a strong background in AI and software, and now you're part of the team. So can you maybe give us a helicopter view of what the Advantest Cloud Solution is for our community?
With Advantest Cloud Solutions, we're trying basically two aspects. So first, we need to put down the infrastructure and the piping, the frameworks for a lot of these solutions to be actually put to work. And that sounds, some perspective, for some people, it might sound trivial, like, well, how hard can it be to put a server somewhere and get started? In reality, there's really a lot of challenges that you have to think of. How do you pipe that data securely between sites, right? By the way, no supply chain is as complex as the semiconductor supply chain, and no supply chain has harder and more varied bottlenecks in their production capacities than the semiconductor supply chain. So the chance, to get something wrong here is very high. So you have to be very careful to do this in the right way. So infrastructure is the first aspect. Infrastructure to enable advanced analytics, AI, software solutions to be put to work within the semiconductor supply chain.
And like you said, how hard can it be? It's like, okay, you're building a freeway and people are interested in the cool cars that are going to be driving on that freeway. But without the freeway, it doesn't matter what car that you have, you're not going to be able to use the system. And I think to point out some of those challenges, physically, like you said, how hard can it be? You're just putting in a server, but the security requirements, because of the complexity of our supply chain, is enormous. I mean, we have customers, suppliers, vendors, and the data and the machine learning that's being applied is super secret. I mean, it's equivalent or nearly equivalent to the design of the chip itself, which you don't want your designs going anywhere. So you don't want your data going anywhere. You don't want anyone else to be able to see that. And you definitely don't want anyone to be able to see the type of models that you're using, how you're using them. So even that's just one aspect, the security, but already that is a huge challenge.
Yeah, and combining the parts, right? I mean, in I think 10, 15 years ago, when the biggest semiconductor companies had most of their insertions or most of their work steps in-house was one thing. But now we have the rise of the fabless, which is now clearly dominating the scene. That means that the whole supply chain has become fragmented to a degree that is to outsiders of our industry hard to explain, and they can't even conceive of that. And if you go then all the way even to final users, I mean, look at automotive OEM, and to bridge all of these gaps, to get the data from the device sits in the dash of your car all the way to the front where a silicon crystal is cut up and put into a lithography tool, and to combine all of that. And that's kind of where we're trying to go with Advantest Cloud Solutions, allowing you this full transparency, getting all the data together, but empowering you as the customer to utilize that data. And we have ideas what we can do with the data. So we have some, to stay in your analogy, we're building some sports cars as well, right? But ultimately, you as the customer know your data best, and you know best how to use it. And we need to work together here, right? But the infrastructure part, we're in a unique position to solve, because we are with our tools sitting in so many insertions in the supply chain already, that it is really, our job to solve this. Because if we don't do it, then nobody else really can.
That's true. I mean, we're in a unique position where because we have tools as far forward as the front end, then at post-silicon validation, at wafer sort, at package, now system level test, and
That's right.
our even more recent acquisition of Assay, which is the socket assemblies. Like you said, now we can start tying all of these data pieces together. And when you do that, the data story and the data value also goes up exponentially. The more you know about that test cell, what the load board is, what the socket is, what the handler is, what the images of the underside BGA looks like, and you combine that with, let's say, the parametrics, the scan, with whatever data is coming off of our testers, that's a game changer. And I think that's why Advantest Cloud Solutions is so interesting.
So my point is, stay tuned. We have a lot of exciting customer success stories to share in the future.
Great. And I'm sure we're going to have you back to talk about those in the near future. So wanted to say thank you for your time today. Okay, that tone means it's time for Junko's top 3 takeaways. I'm joined by Junko Nakiya, who is part of Advantest Global Marcom team. And she's here to talk to us today about Semicon China. Junko, take it away.
All right. Thank you, Keith. Well, for obvious reasons, I couldn't really visit Semicon China this year. So I gathered some information from my colleagues in China who were actually at the show site. So here's my first takeaway. Semicon China is still strong and continues to grow. This year, about 90,000 people visited Semicon China, doubled from last year, almost like back to normal. And I also heard that all the booth space for next year was already sold out. So it's great to hear that so many people are back at the show this year and are already planning for 2022. It's very encouraging.
So Junko, that aligns with the chip demand continuing to rise. China continues to invest with the latest semiconductor imports surpassing $300 billion this last year.
Here's my second takeaway. The hottest topic at Semicon China continues to be around automotive and Industry 4.0, or automation and AI. 5G is very popular, but automation and AI, they were just everywhere throughout the show.
Interesting, Junko. Seems everywhere we look, AI captures all the headlines these days.
Yeah, that's so true. Again, AI is everywhere. All right, to wrap it up, my number one takeaway is a shameless plug, our V93K exascale with Extreme Link technology. We showcased at Semicon China was a big hit.
And that's how we are advancing Industry 4.0. Thank you, Junko, for that Semicon China recap. I look forward to the next Junko's top 3 takeaways.
All right, thank you, Keith.
And now here's Tish with some Advantest updates. Tish?
Thanks, Keith. In this episode, I want to talk more about our Virtual Voice 2021 conference coming up June 21st through the 23rd. So let's talk about the program. We have about 70 technology papers, 2 great keynote speakers, and a featured industry talk from VLSI Research, a technology kiosk showcase with 19 topics, a partners expo featuring our headline sponsors, Alliance ATE and ISE Labs. We have virtual booths, virtual kiosks, awards, entertainment, and of course, some surprises. And if that's not enough, we also have Workshop Day on June 24th. To learn more and register, all you need to do is visit the Virtual Voice website at voice.advantest.com. Also, be sure to connect with Advantest on Twitter, Facebook, and LinkedIn for all the news and much more. Keith, that's the latest. Back to you.
Thanks, Tish. And that wraps it up for another successful Advantest Talks Semi. See you next time.